Hi, everyone, and welcome to today's webinar organized by JetBrains. I'm Paul Everett, PyCharm Developer Advocate, and I'll be your host. Today, we're joined by Matt Harrison, Python data science author, trainer, and speaker. And really, we're fortunate to have Matt give our first webinar on data science. Matt, if I recall correctly, you were at PyColumbia last month. Let me guess, a lot of data science being talked about, right?
Yeah, I was lucky enough to have the opportunity to go down to Colombia, Medellin, and participate in, I think, their second PyCon Colombia, and it was awesome. Lots of interest from students, lots of web stuff, but also a ton of data science stuff. They had professors there talking about how they're using these tools for teaching. They have people using it in industry, so a lot of cool stuff going on and a great opportunity to go to a little regional small conference. It was a lot of fun.
Also, during the run up to this webinar, when you and I were talking, I know you've got your name on a lot of books, but I believe you also had to juggle your training work with updating your Learning the Pandas library book. How's the book update going?
Yeah, so the end of last year, I released an illustrated guide to Python 3, and that went really well. And my Pandas book has been out for a little bit over 2 years and needs some updates, needs some of the latest and greatest. So I'm sort of knee deep in that, juggling that, and hopefully, what I'd like to do is sort of have a public people who are interested in doing beta reviews, interested in getting people to help out with that. So that's useful for me as a self-publisher to get feedback on that and get people the content they want. So I'm knee down deep in that and looking to sort of broadcast that information out to get people who are interested and sort of getting a preview look at it, helping me out.
Yeah, and that's a good point for the audience. Give feedback to Matt so he'll know which direction to steer things. We're really lucky that he's out there doing these things. It will help him and therefore help us to give him some feedback. Matt's going to get us introduced to Python data science and pandas today using an interesting format and an interesting topic. Matt, give us a quick peek on the format and the topic.
Yeah, so wanted to just briefly go over what data scientists do, and that's an overloaded term. There are many data scientists, and you ask 10 people for a definition of that, you get 10 answers. But just wanted to look at some Bitcoin trading information and see if it would be possible to implement a very simple algorithm to determine whether or not you should buy or sell Bitcoin. So seems to be a hot topic right now, lots of interest on that, and maybe right now is whether you should sell your Bitcoin or not.
And for the format of Jupyter to PyCharm, can you talk about that a little bit?
Yeah, sure. So I'm going to, what I plan on demonstrating is how a lot of data scientists use a tool like Jupyter. And so I'm going to sort of work through Jupyter, and then we'll talk a little bit about like productizing the code that you've put in Jupyter, because people tend to be loose and sloppy in Jupyter, and we'll see how PyCharm can help us do that. And I've just shared my screen. I've started a little Jupyter notebook here, and let's sort of get going. So I'm going to assume that people who are watching this are newbies, don't have much experience with, maybe have experience with Python and PyCharm doing programming, but maybe not so much from like the Jupyter data science side of things. So I'm not going to assume very much knowledge there, but I'm just going to make a little notebook. So Jupyter Notebook, or Jupyter, is a tool that we can make notebooks. We can make literate notebooks. So I can type code in here. I can type text in here as well. Right now I'm typing some markdown text, and you'll see that I can do things like render this and put in HTML or whatnot. So I could say, here's my Twitter handle. It's Dunder M. Harrison. And then I hit Control Enter to render that. So I can also type in Python code as well. So I can say name is equal to Namat here. I can run that, and then I can say, whoops, I can say print my name, and it will print that out for me. So this is Jupyter is a tool that real life data scientists use to do their work. So just put in a little piece of code here. Here's a little snippet that I can put in, and then if I have a snippet like this, I can run this snippet to like oh, here's my book. Here's a link to my book, and embed that link in there. One thing you may or may not know is last year or so, gravitational waves were discovered, and so there's a big hubbub about that. I'm not a physicist and don't pretend to really understand what's going on there, but one of the cool things about that discovery of gravitational waves is that when they were discovered, they posted that as a Jupyter notebook. So you can go in and you can read, and there's text about it, there's all the code. You can go in and basically validate that discovery, which was pretty cool. So I noticed one of the questions here was, what does a data scientist do? So I'll answer that by using Big Data Borat, a semi-famous Twitter who now seems to be dormant, but he said in data science, 80% of time spent prepare data, 20% of time spent complain about need for prepare data. And this has sort of been my experience as well, that as you're going through looking at some data, maybe trying to make some predictive models about it, a lot of the time you just need to figure out what's going on with that data, where it's coming from, how to deal with it. And that takes a lot of time. And sort of the sexier part where it's like, oh, we're gonna make this model and do these predictions, that's like the last tail end of what you do. So a lot of it is just getting down and dirty with the data, understanding the data, understanding why data is missing and whatnot. So let's sort of dig into this, and I'll show you an example with our Bitcoin stuff here. So I'm going to put just an import statement here. It's going to import a bunch of libraries. Got a little deprecation warning because one of the libraries that I'm using is Yellowbrick, which is a visualization library, and it's using a deprecated version of sklearn, but it shouldn't affect us here. One thing to note at the top of this cell that I just typed in here, this matplotlib inline, is that this is not Python code. This is code to tell Jupyter to render plots to use the inline backend for matplotlib. And so when it renders plots, rather than opening another window, it will just open them in the web browser, which is kind of cool. Okay, so I've got some Bitcoin data here. I just got it from, let me copy the link here. So here's the link where I got the Bitcoin data from. It's just a Kaggle project, so Bitcoin historical data. And I've downloaded that data here, and I've got it in a directory. So I'm just going to make what's called a data frame. So pandas, you may or may not have heard of pandas. I'm importing this pandas library, and I'm importing it as PD. So developers like to be lazy, and this is just a little common convention to people rename their pandas library as PD. On that PD library, there are a bunch of functions that we can do. And one of those is that we can read CSV files. And so I'm just going to read the CSV file that I've got here, and I'm going to put it in what's called a data frame. So I'll run that, and it's going to think for a little bit. And at the end here, after I've run that, I should now have this DF guy, this bitdf, which is a data frame. And you can see it looks like columnar data. I've got along the left-hand side, I've got what's called an index. This is, you could sort of think of it as a primary key or a row index in a database. And then along the top here, I've got some columns, and I've got different values in here. One of the nice things about Jupyter is that it has some integration with pandas. So rather than just printing out text, it actually prints out a nice little HTML table here. So we've got a couple columns here. We've got a timestamp. We've got the open during that timestamp, the high during that timestamp, the low, the close, the volume in Bitcoin, the volume in some currency, which I believe is dollars, and a weighted price value at the end. So one of the things we might want to do is say, oh, is this going up or down? Can we make a predictive model that allows us to buy or sell Bitcoin based on that? So I just want to take you through some of the steps that a data scientist might do to analyze that. Now, I will note beforehand, I'm not an investment advisor here, so I happen to have some Bitcoin, but I'm not saying buy or sell. That's your own choice, and I'm not a quant either, so take this for what it's worth. I just want to give you show you some of the things that pandas can do here. So one of the things that we can do is we can look at the different types that we have in here. So if I say on my data frame, I look at the dtypes attribute here, it will return me what's called a series, and a series you can think of as a column in this data frame. But this series gives me all the columns in this left-hand side, which is the index, similar to this index above, and it's giving me the types for each of these columns. So we can see that timestamp is an int, and everything else is a float, which is pretty good. One of the things when you're making predictive models, typically you want everything to be numeric. Most models don't deal well with text data. One of the things that we have here is that timestamp is an int, and there can be value in that, but we might be able to extract more value if it wasn't an int, maybe if it was a native time stamp item. So one of the things we can do is we can invoke what's called the toDateTime function on this, and I'm just going to say I'm going to call on the bitdf timestamp column. I'm going to call toDateTime, and because this is unit second since the Unix epoch, I'm going to say the unit here is S. That's just shorthand for saying that it's seconds. And you can see when I do that, it gives me back another series. But now this series, if I look at the very bottom here, it says that this is a date time series. So Pandas has some nice code in here to convert text data or string data into objects that have a little more structure to them. And so in this case, I'm dealing with a timestamp, but it could be the case that if I have, something that said March 20th, 2018, Pandas would be able to parse that as well if it was a string. Let's look at some other things that I might want to do here. So maybe I'll come up here and I'm going to say, so on this guy here, I'm going to say, let's make a column called bitdf date, and he will be equal to the result of this guy. So I'm just going to make a date column and stick that in there. Okay, and maybe since this is kind of taking a long time, I'll just put time up here and see how long it takes. And I'll put a double hash up there, and I'll time my cell. Let's see here. Okay, so this double hash here, this is cell magic. It says, how long does this host cell take to run? It says it takes about 3 seconds to parse that and convert it to a CSV file. Let's look at some other things that I might want to do here. I've got this date column now. What I can do is I can say bitdf, I want to set my index to the date. And let's look at that, set index to the date column. If I do that, I get back a new data frame, but you'll note that the index has changed. It's now a date index. And so this is, you can think of this as a time series data frame. So I've got dates along the side here, or times along the side. It looks like it's at the minute level. So we've got some fine-grained information here. Some other things that I might want to do is I might want to rename some of the columns here. So I've got like open and high and low and close. Maybe I want to rename those. I can do something like this, where I say, and I'm actually going to chain these together here. So I'm going to do something that might not look familiar for people who are used to writing Python code, but for people who are doing this Pandas work, this is somewhat familiar. What you do is you chain these together. Typically, when you call a function or a method in Pandas, it doesn't mutate the original object, it gives you a new object. So this is going to give me, we can see that this returned back a new data frame. So on that data frame that it returned back, I'm going to say, let's rename, and we're going to name the columns here. I've got a little dictionary that's just mapping those columns, what they're going to be. So I'm just going to paste that in here so I don't have to type it out for you. But it basically giving me some names that are a little bit easier to type and are maybe PEP 8 compliant. So if I run this now, you'll see that it complains. I'm missing a parenthesis at the end. Okay, there we go. So what I've done is I've reset my index on my original data frame, and I've also renamed those columns to something a little bit more maybe Python user-friendly. So TS, time series, open, high, low, we lowercase those, and we change those other ones to have underscores in them. let's do a couple more things. So one of the reasons I put this as a time series is because when it's a time series, I can do something really cool. So I can call what's called the resample method, and I can say, I want to resample this by the day. If I run that here, rather than getting back a data frame, I get back this date time index or index resampler object. And what that allows me to do is on that, I can say, I want to aggregate. I'm going to group everything. Everything in there is by the minute. I'm going to group everything from the same day. And then when I get all the information from the same day, I'm going to apply an aggregation function. And I can do a bunch of aggregation functions here. So I've got a little mapping of all the aggregation functions that I'm going to do. And I'm just going to plop that in here. So I'm going to, on the open, so when I group everything from the day, for the open column, I'm going to take the first value. So that's where the day opened at. For the high column, I'm going to take the mean, so the average of all the highs throughout the day. For the low, I'm also going to take the average of all the lows. And for the close, I'm going to take the last value. And then I'm just going to sum all the volume for the Bitcoin and the currency. And for the weighted price, I'm going to take the mean, and I'm going to take the min from the time series. So let's just run that and look at what happens here. So this is pretty cool. From basically, I mean, this is like one line of code. Well, you could think of all this as one line of code. It's a long line of code, not PEP 8 compliant, but I put these parentheses around it to make it sort of a little bit more readable. But now I've changed my data frame. Rather than being on the minute granularity, it's now on the day. And we can see that we're pulling off the first open value, we're averaging the high and the low, we're pulling off the close value, we're getting the volume and the sum. So pretty powerful stuff that we can get from using pandas there. A couple other things to note here is that maybe we see that there's these NaN values in here, so that means we're missing data. One of the things that the data scientist has to do, like Borat said, is sort of clean this up. So why are we missing data here? You know, did someone not have, was Bitcoin, you know, some of these, wherever they're pulling data from, was that down on December 5th, 2014? Questions like that, a data scientist would have to dig into. Sometimes you can sort of cheat and say, we're gonna do the nuclear option here. And I'm just gonna say, well, you know what? I just want the last 1,000 rows here. So I'm gonna do, there's an attribute on a data frame called iLoc, and I'm going to say, I'm going to slice that and take the last 1,000 values here. And you'll note when I rerun this, the date will change here. And now I'm starting from 2015, and hopefully I don't have any missing values in here. Problem with missing values, again, is when you make a model that has missing values, the models don't really deal with that very well. Okay, the next thing I want to do is I just want to make a column for buying. I want to make a column for buying, and how I'm going to do that is I'm going to do the shift operator. So I'm going to shift the close column. So here's the close column right here, and I'm going to shift it -1. So what that means is I'm going to say, let's look at, if I shift it -1, it will give me a new column here where everything in close is moved up 1. And so I can use that to make a model where I train it, where I say, is the close tomorrow better or worse than today? And I can say, well, maybe we'll buy or sell based on what the close tomorrow is. So again, I'm just going to put, I'm going to say, like, let's do an assignment here, and I'm going to assign, I'm going to take a lambda x. We're going to make a column called by, and it's going to be equal to a lambda, and the lambda is going to take the data frame, and it's going to say on the close, I'm going to shift that, if I can type here, shift it -1, and if that's greater than the x.close, I'm going to also, that should return a Boolean, and on that Boolean, I'm going to cast that to a type here as type int. So that's sort of a lot of stuff going on here. So one of the things to note about pandas, I'll just go on a brief aside here, but if you look, so they print the dir, all the attributes of the data frame here, there's like 400 different attributes and functions and or methods that you can do on that. So very rich API, a lot of stuff to sort of dig into and learn. So we don't have time to sort of dig into that all right now, but okay. And then maybe the last thing I want to do is, if I look at the last guy, because I shifted that, maybe I want to pull off the last column or so, or the last row. So maybe I'll do something like this, where I'll say, let's just take iLoc and go up to the last row here. Okay, so in sort of a couple minutes here, I've sort of gone through, like, this is the 80% of time that I would spend tweaking data. And this is, so maybe we say like bit df is equal to this, and we'll pull off, maybe we'll do something like this. We'll make sort of a big, hairy cell here. We're gonna say, we're gonna read it, then we're gonna set our date column, and then we're gonna do all this other stuff. We could combine this if we want to, but we'll just leave it as this right now. And let's run that, see how long this takes to sort of do all of our processing on this guy. So it takes about 3.8 seconds. And admittedly, if you're new to pandas, this might be a little hard to read or whatnot. But there's a rich API here, and this is what people spend their time doing a lot of the time for data science. So let's take a break, or not a break, a question. Let's see if there are any questions here. So I guess, Paul, do we have any questions we want to look at, or?
You betcha. All right. Try not to go too deep on any of these because we have a bunch. First one's pretty easy. Matt, do you have any online courses regarding data science?
Okay, so I'm currently do a lot of instruction with O'Reilly, and they have some live series on Safari Online. So check out those if you're interested. And I go into pandas and predictive analytics. I got 3 different courses dealing with that. So,
all right. Okay, this one's a fun one. So what does a data scientist do?
Yeah, I mean, sort of the joke there is that a data scientist determines what ads you click on. That's what data scientists do.
That's so sad.
Yeah, the best minds of our time are determining what ad you click on. But everyone, there's a lot of data sitting around there. People are getting more data. And so I think data science, rather than like making models and that, they're going to be looking at that data, explaining that data, and trying to communicate that data. I think that's sort of the key thing, because I think a lot of these things that we're doing as technology improves, we'll be able to automate a lot of it. But there's going to be a part where we need a human to sort of go in there and say, yeah, this is, we're missing census data, and this is why the census data was missing. And the computer may or may not be able to infer that, and then be able to take that output and deliver it back to the business owners, right? Yes, you should buy Bitcoin. No, you shouldn't. Yes, you should spend money in these places, or you should upsell to these people, or you should look at this oil line here, because according to my models, we're predicting that this is about to fail or crack based on past performance, those sorts of things. So, but again, data science, this is a new term that's hasn't even been out for 10 years. Lots of things that data scientists do in real life.
Let me ask a follow-up on that. Do you think the data scientist is the person sitting in front of pandas in a Jupyter notebook? Are they the ones reasoning about the data, or just providing the analysis to someone else?
Yeah, I think there needs to be a combination. If you're going to dig into the data, I think you need to have some ability to dig into the data. And admittedly, a lot of data science, quote, is done in Excel, right, where people can dig into that data. But there's also got to be that human connection, or connection with the business group or whatnot, to be able to infer or reason about the data, or talk to the correct people about that. I think that's where the most value is going to come. If you want to sit back in a corner and just dig at data the whole time and not communicate with anyone, it's going to be hard to pitch yourself as a data scientist.
Let me ask kind of an inverse of that, and it's a question we ask internally at PyCharm a lot. Do data scientists consider themselves programmers?
And that's another good question. So because this is sort of a new field or a new name, there's been, definitions. What is a data scientist? And someone says, well, it's someone who does statistics better than a programmer who knows statistics better than your average programmer, or it's a statistician who knows programming better than your average statistician. I mean, I think those are valid points here. I think being able to program is definitely a good skill, and being able to automate things and take things that could take a long time and do those quickly with a computer, those are good skills. And as your data gets bigger, the ability to program and take advantage of sort of distributed systems and larger systems for digging into, big data in quotes, programming is definitely a skill that these data scientists should have.
All right, let's speed through some detail kind of things. Is there any way to unpack binary data and convert it into an Excel file?
Unpack binary data. So Python has ways to do that. I mean, I'm trying to think, have I ever dealt? Typically, I'm dealing with SQL or I'm dealing with CSV. So that's where I see most of my work, but obviously Python can deal with binary data. You might need to write some little tools that sort of tweak that and pull that apart for pandas. There are other formats that pandas support, so yeah, definitely you can do that. I'll just show you some of the, so there's all these formats: Feather, CSV, Meshes Pack, Parquet, Pickle, SAS. So, but I'm typically seeing CSV files and Excel files, and pandas can do both of those.
Are there right under equivalents for those?
Yeah, there should be. So actually, it's not on. It's on the data frame where we would write that.
Oh, got
so
it. That makes sense.
So I think we say to, yeah. So to Feather, to Excel, to JSON or Pickle, or sort of too many things that you can do there.
All right, next one. Cool places to find data. This person suggests a subreddit /r/datasets. I know Kaggle is a place. Can you suggest some other places?
Yeah, Kaggle is a good one. There's the UCI. So I just pull up the link here, UCI dataset. So so here's the machine learning repository here, University of California, Irvine. They've got a lot of sort of traditional data sets, the iris data set, there's a wine data set, but they're adding more data sets as well. So that's another good resource for looking at that. I'm sort of the opinion, if you want to dive into something, a lot of people have their own data set, right? I mean, I have like Strava data sets about me. So find something that you're interested in and see if you can find a data set, or if you have a local data set, and see if you can do something that's sort of personally applicable if you're doing this on the side or at work, something that's applicable to your work.
And people don't just share data sets, they share notebooks, right?
Yeah, there's a lot of notebook sharing going on. So as you mentioned, Kaggle, if people aren't familiar with Kaggle, it's sort of a competition where they say, we're going to compete to build the best model here. And there's a lot of good resources there on Kaggle. And one of the cool things is the community in Kaggle, where they'll share their notebooks and sort of comment on those and allow people sort of an open source mentality where people can build and combine their models that way. So I'm all for being able to look at other people's code, see what other people are doing. And like I said, sort of the impetus for my book has been reading through what other people are doing with pandas and whatnot, and trying to incorporate that into my upcoming book.
Someone's asking, is there any way to get your notebook or the Py file for it?
Yeah, great question. I will put this on my GitHub. So my GitHub is Matt Harrison. So I'll just upload it there sometime after. So.
And we will let everyone know in the follow-up email.
Okay.
Can you take a few more specific ones?
Sure. Yeah, let's do it.
What is the percent time equivalent in PyCharm? That's one more for us. So we will answer that. Ernst, if you could take that one. I didn't read the full question before asking. Is there a way to resample a time series to a specific number of entries? If I have 100 data points, I want to resample to only 10.
Yeah, so the resampling, so this is specific, this resample here is specific to time series, right, where I have an index that is a time series. But there's a more generic version of that called group by. And group by will apply to any data frame or any series in pandas. And you can pass in arbitrary functions to determine how to do that group by. So you can group by columns if you wanted to, and you could make a column that has 100 entries and then the next 100, and you can give those the same value, or you could pass a little function in there that would do that as well. So definitely able to do that. One of the cool things about pandas is this group by, where you can aggregate and then summarize, roll up your results there.
All right, we have a question asking if you could re-review the .assign.
Okay, yeah, quickly, yeah, went through all this really quickly, but what the assign is, so up here we have basically an index operation to make a column here, and the assign is a way to do that inline, so we can do this sort of chain operation on the data frame here. And so what it's saying is it's going to make a new column. The column has to be a valid Python parameter name here, so by is going to be the column, and we're just passing in a callable in there. The callable is going to take the whole data frame, so X is going to be this bitdf data frame, and then it's just going to return some value here. And so I'm shifting up the close, and I'm saying, is the close of the next day greater than the close of today? And change that to an integer. So it's going to make a Boolean value there, and then I'm going to cast that Boolean value to an integer.
We also have a question on that same line. What does the lambda notation mean, which is a nice way to get into the vast underbelly of Python language arguments over the decades?
Yeah, I mean, we can talk about Python 3 and how there's rumblings to remove that from the language, but yeah, so lambda, if you're not familiar, is a way to make an anonymous function that was added, I believe, in Python 1.4. Pull request, someone who was very familiar with functional programming wanted to get like lambda and filter and map into the language, and Guido accepted them in, and later he sort of lamented that. But yeah, this allows me to just say, this is a function that takes X and it returns this guy right here, whatever's after the column. I could define that as a function as well, but just allows me to inline it there.
We're only halfway through the question, so one last one and let you resume. What is the best way to export pandas data frames into MongoDB?
That's a good question. I mean, I haven't messed with MongoDB a lot. I've messed with Couch, but I'm assuming you want something like this. So there's a to JSON here. So we could do that, and here, this is giving me JSON results for the whole column here. So that might be a step for you to get it into Mongo. I'm not a pro at Mongo, so I can't really say like what schema you should use or whatnot, but definitely have the ability to export to JSON.
All right, back over to you, Matt.
Okay, cool. Great questions, guys. So let's build a little model here. And what I'm going to do is I'm going to make a random forest. So if you're not familiar with a random forest here, the idea behind a random forest is that, you know, if I had a jury and I said, I'm going to have 2 people on the jury and each of them have 60% chance of making the right verdict. There's a theorem called Cortis's theorem, French, I guess, philosopher from the 1700s, and he basically said that if you have anyone who has a greater than 50% chance of predicting the right verdict, you might as well add them to the jury because they're going to help the jurors make a better decision. The random forest is sort of a similar thing where we're going to make a bunch of decision trees. So a decision tree is where you sort of say, is this true or is this true? And if so, you sort of go down this path, sort of like what a doctor would do. And at the end of the path, you can say whether you should buy your Bitcoin or sell your Bitcoin based on sort of your input columns. Random forest basically says we're going to make a bunch of decision trees, but we're going to randomly choose which columns we allow to influence those decision trees. And then we'll combine all those decision trees into this forest of trees at the end. And hopefully if those decision trees have a better than 50% chance, the more we add, the better that will be. So what we need to do is we need to make what's called an X column and a Y column. These are what machine learning parlance we do to say X is our features that we're going to predict from, and Y is our output, our target. So what I'm going to say is I'm just going to ignore the by column here, and I'm going to say the columns that I'm going to use, I'm going to make a little list comprehension. So I'm going to see C for C in bit df dot columns, if C not in ignore. So let's get some columns here. And I gotta fix my typo here. Okay, and so now I have some columns that I can use for X. So I'm gonna say X is equal to bit df columns, and my Y is going to be equal to bit df dot by. Notice I'm using a capital X here, which is sort of a violation of PEP 8, but this is a convention chi in machine learning, so everyone just accepts that violation there. So I should have an X and a Y now. We can just briefly look at those. So here's capital X. And so here's a row of data here, and this is what I'm going to determine for our Y if I should buy, 1 as a buy or 0 as a sell for that day. So we're trying to use that X to predict, to make a model that tells us whether to buy or sell. That's the gist of our little model here. And one of the things you need to do when you're doing machine learning is you need to split up your data into a test data set and a trained data set. Reason why you'd want to do that is because if you give it all the data and then you evaluate how it does on all the data, well, I mean, I can make a model that does really well on all the data because I can just memorize the whole data. So I want to see how well the model, we're going to say, generalizes to data that it hasn't seen before. So so I'm using the scikit-learn library now. Scikit-learn has some ability to take pandas data frames and use those. And I'm using a module called the model selection module. And in there's a train test split function that's going to split up my data. And I'm going to say, I want to use 30% of my data, 0.3 for testing. So if I do that here, I need to say random state instead of random here. And random state just allows me to make this reproducible, so it gives me the same results every time I run it. Okay, so now I should have a testing data set, and I can say, here's the size or the shape of my training data set, and the shape of my test is 300. So we have 30% for testing and 70% for training. I'm going to make a random forest here. So I'm going to say random forest, I'll call it RF1 is equal to the ensemble model. Ensemble is a module in the scikit-learn library. Again, the scikit-learn library is a great library. This is a library that people who are real data scientists are using in real life. This isn't just a toy library. It's built on top of things like NumPy, so it actually goes really fast. And we'll just put a random state of 42 in here again, so I get the same results if I run it multiple times. One of the nice things about the scikit-learn library is I can say there are a bunch of different what are called classifiers and regression models, and they all have the same interface, so I can split these out very easily and try out different models here. So I'm going to say, I'm going to call the fit method here, and I'm going to say I want to fit this model, I want to train it on x.train and y.train. So given x_train as an input, it should try and make a model that gives me y.train, and we'll run that. And then we'll also say on that, I want to score it now. I want to say, assuming that you've never seen x_test, I want you to predict what you get on that and compare it to y_test, which is the actual value there. So let's just run that here. It goes pretty quickly, and the score comes out as 0.49, which is actually not a good score. That's about, basically it's saying that it's guessing here. So let me just briefly illustrate why we want to split this data up into testing and training. If I score on the training set here, I get a 0.97. So what that tells me is that it's sort of, this is what we call overfitting. It's memorizing the data, or it's not generalizing to data that it hasn't seen before. So that's not particularly good. Let me just quickly show an evaluation method here. So I'm going to use this library called Yellowbrick. This is a library that is in process. I actually submitted a bug report to it just a week or so ago, and they're making some progress here, but it allows me to do visualizations that are specific to machine learning models here. So I just copy and pasted some code in here, but I'm going to make a matplotlib subplot, and I imported from Yellowbrick, this Yellowbrick library, what's called the ROC AUC class, and I'm going to pass my random forest in there. And then I have a method called score that takes the test data set and so X test and Y test, and then I say poof. I call the poof method, which is sort of a silly name, but we're in Python, and that puts a little matplotlib visual up on my screen. So this is what's called an ROC curve. I'm going to shrink my screen a little bit so you can see it. But so it's graphing the false positive rate against the true positive rate, and you'll see there's a dotted line up the middle here, and there's some other lines that tend to track that. This is our bad data set. Remember, this one didn't do very good. What you'd like to see is something a little bit more like this. Here I'm going to rescore it given what it was trained on, and you'll see that the curve actually comes up here, and the area under the curve is about 1. So how people evaluate, one of the methods for evaluating a classifier is looking at this ROC curve, and if the false positive to true positive rate is a good rate, then the curve will sort of rise up above this 45-degree line here. In this case, what it's telling me, the 45-degree line is actually guessing. And in this case, it appears that my model for predicting whether to buy or sell Bitcoin is actually worse than guessing. So I'm going to take that for what it's worth. Again, I'm not a quant, but obviously there's probably some things that people who are buying and selling or day trading these things, some things that they're doing to divine some information there. So brief example of making a model here. Note that making the model is actually pretty simple relative to the processing we did with pandas beforehand, and then some evaluation of the model using the Yellowbrick library. Let's see if there are any more questions, Paul.
First, your model may be worse than guessing, but you say it in such a confident voice that I believe you.
Yeah, send me your Bitcoins and I'll tell you whether to buy them or not.
Okay, how about we have a bunch more questions, but the last set of questions sucked up about 15 minutes of time. We have a bunch of people waiting to see PyCharm. So how about we go and get a little bit into PyCharm before
let's do some PyCharm and then wrap it up. Yeah, let's do that. Okay. So I'm just gonna pull up PyCharm here. I've already got it running here, and let's look at so what I've done here. I mean, if you're used to Python programming, this is like super sloppy Python code, right? This is all done at the global level. If someone saw this in a code review, they'd be like, you need to do this and this and this. It's not PEP 8 compliant, blah blah blah. So let's just look at this. At some point, we need to productize this. So I'm going to make a file called bc2.py here, and I'll just plop in my pandas code into here. And so you can see that I put my pandas code in here. Again, this is all happening at the global level, so I probably wouldn't want to do this. I'd probably want to make this into a function here. So one of the nice things about using something like PyCharm is I can just highlight that, and I can go over here and I can say refactor, and let's extract. We're going to extract a method, which should really be a function, but we're going to call it a method, and we're going to say get bitdf here. Okay, and you'll note that it put it into a function for me. Pretty nice. Let's do some other stuff here. Maybe we want to take this guy right here. We can see that this is sort of a magic number, right? This string here. So let's just copy or highlight that line here. Whoops. and we'll say refactor, and we're going to extract, and we'll extract a parameter here. Cool. So just using something like PyCharm with its great abilities to do some refactoring here, we can pull out sort of these magic numbers here, and it note that it defaulted to that, so we could remove the default if we want to. Here's another magic number down here, this resample. Maybe we would refactor this, and we could say, let's extract this into a parameter as well, and this is the resample period. Note that pandas has a bunch of different ways of resampling. We resampled by the day, and you can resample by the minute, the hour, every third week. You can do a bunch of different things there. So this just allows us to resample by the day. And maybe we need to come down here at the bottom here, and we need to say return bit df here. So this is something that, you know, in 30 seconds, I've basically been able to like productize this pretty well. I've been able to refactor it, push it into a function here, pull out some of these magic numbers here. I'm calling this path here a magic number because it's hard coded, and maybe we want to provide different values there. And if you're into like Python 3, we can even go further down that. We can say, well, a CSV, that's an int here, and a resample period, that's a string, str, and this is going to return pd.dataframe like that. Oh, I've got, let's see, I need to import pandas. Okay, so let's import pandas. That imported it as that. So pretty nice functionality there. Note that, let's say like I want to get file foo.csv, and I want to do it at the year level or something like this. Note that I get an exception here because I'm using type annotations in Python 3 style type annotations. It said I expect to get an int here, and I got a string. Whoops, that's because this is really not an int. This is a string here. I typoed that, and you'll see that PyCharm has the ability to utilize this new functionality in Python and make your code more robust and give you hints and warnings. Other things that are really nice about PyCharm here is I can do something like this where I can say, oh, here's to date time. I want to go to the implementation of that. And it will pull up the to date time implementation in pandas, and you can read this. One of the things that I do a lot of corporate training as well, and in addition to sort of virtual and live training, I go to companies and teach them how to use Python and also how to use, you know, these data science tools. One of the things I encourage is just reading other code and getting used to reading code. And PyCharm makes it really easy to inspect this code rather than having to like grep through this. Note that this pd.toDateTime is not in the pandas module, it's in the datetimes module. So having to sort of grep through that or find that can be sort of a pain here. We can do a similar thing here with set index here. We can say, let's go to the implementation of that. And it's going to say, well, there's a couple set indexes here. There's one in idle, and there's one in the data frame. So we want to go to the data frame one here. And here we have the implementation for set index right there. So this is awesome, and it allows you to be super productive here with your Python code. Note that this code looks quite a bit different than this, right? Being able to have stuff at the global level here and inspect it, that's important when we're doing our exploration. But when we want to productize and harden our code and we want to deploy it in real life, we don't want to have global variables sitting all over the place. And we want to be able to, you know, run our code. We can do things like add annotations to make it more robust and write test cases and whatnot. And PyCharm's a great tool for that. So I think that's sort of the gist of my PyCharm spiel there. But again, at some point, someone's going to have to take and productize your code, and great tooling there to do that. Should we go back to some more questions?
Yeah, sure. I'm going to go through some of the detailed questions and then come back to some of the conceptual things about data science afterwards.
Okay.
Does that sound right?
That's great, yeah.
All right, can you apply predictive or machine learning models to a data set using pandas?
Okay, so Pandas itself does not do any modeling. What Pandas is it allows you to tweak data. So I sort of liken it to one thing to compare it to would be like an in-memory database, right? You have a database that has a table, and you can add columns, remove columns, make a new table, aggregate things. So typically where people use Pandas is in the pre-processing in order to process their data such that they can stick it into like a scikit-learn model. That's where people use Pandas. Pandas itself isn't focused on doing any predictive modeling or that
Got
sort
it.
of thing. You need to use a scikit-learn for that.
And boy, the Python ecosystem for all of this is just flourishing, isn't it?
Oh yeah, I mean, I
GPU
should note that, like,
accelerated.
sorry, I didn't mean to cut you off.
No, just GPU accelerated, massively parallel kinds of systems.
Yeah, there you've got that. You've got the deep learning stuff using TensorFlow, and one of the interesting things I think in the pandas world coming out is that pandas is now becoming, there's the pandas implementation, but pandas is sort of becoming sort of similar to Python, where it's actually a standard as well. So you've got tools like Dask, you've got Spark, you've got
Right.
Ray. These are tools that are using pandas interfaces, these same interfaces that people who know pandas know, but allowing them to now, instead of process in-memory data, take it to big data and take it to a distributed system. So that, I think that's a really cool thing. You know, just a couple weeks ago, Ray sort of came out with some benchmarks, and they're saying, hey, you can use your same pandas code here, and you just swap out the import, and you're going to get an X number increase in speed by doing that. Really cool stuff going on there.
I know some people that are listening just heard you and said, what the hell is he talking about? Are there any podcasts or anything that help to explain and guide the Python data science universe?
That's a great question. I mean, I am not there. There's a bunch of machine learning ones, but I'm not aware of any that
Sure.
are Python specific. I mean, I know that, you know, Michael Kennedy and the
Yeah.
Python and Init guys occasionally sort of delve off into that, but there's nothing
Mhm.
super specific in that. Maybe that's an unmet
All right,
market.
specific question. Any places to find free healthcare data?
Free healthcare data.
Feel free to say that.
Um, yeah, I'm off the top of my head. I don't know. I mean, Kaggle. There's probably some Kaggle stuff. I mean, I think there was a breast cancer one on the UCI. So there's probably some stuff like that. I mean, another option for looking into this is there's some of these MOOCs that are coming out. They've got like, they're coming and sort of catered towards a specific vertical, right? It was like deep learning in medical or deep learning in finance or whatnot. So it
Hmm.
might be interesting to go to one of those MOOCs and see if there's some data sets there that might be applicable.
All right, cool. What is the scope of the modified data frame?
The scope of the modified data frame.
This might have come in like 20 minutes ago.
Yeah.
What modified was in parens.
Uh-huh. So, I mean, when I'm in Jupyter, everything's at a global scope. So I'm just
All right.
basically populating things at the global level.
All right. Question about the percent time operator. They were asking about PyCharm, knowing about it being one block. A couple of questions came in, so I'll just try and answer that. You can do it yourself by wrapping that with a called date time to get the start time and lapse time. But there are also some decorators you can get to make it easier to wrap your code. Let's see. Our project recently updated our pandas version. Some of the small updates impacted our key logic, causing a lot of rewrites of models. Have you had that experience before? Any suggestions?
I mean, I've been using pandas for probably 8 years or so. Yeah, there are some things that have changed over time. They tend to be pretty subtle, but you know, it's not even hit 1.0 yet. So the
Yeah,
interface is still, you know,
that's
up
a
for
good point.
grabs.
That's a good point. Three very specific things about what you were showing. What does random understate equal 42 mean? Is 42 a specific parameter, or are you randomly assigning the number?
Yeah, great question there. So when we're using the random forest and I'm like creating models and comparing them, I want to make sure that the model I'm using always gives me the same result. So what I'm doing here is seeding the random seed to this number 42. Otherwise, it's going to randomly choose different trees every time, which might alter my results here. Let me just show an example here. I'll change this 42 to like 41, and we can see that that value is changing, right? So by keeping it 42, the value stays the same the whole time. So it's apples to apples.
All right, cool. What metric is the score method using under the hood?
That's the R2 method or metric. So one of the things you can come in here is you can just say, let's look at, so returns the mean accuracy of the given test. So that's the metric there.
All right. What is the ROC curve?
Yeah, the ROC curve, this came out, I believe, during World War II to predict whether radars could see tanks or not. I believe that's sort of the source of that. And it's, you know, not super intuitive per se, but here's your false positive rates along the bottom, and here's your true positive rates. So you want to have true positives. You don't want to have false positives. So what you really want this to do is you want it to sort of shoot up here and sort of right along the top here. But what you'll see in practice is you'll see some guys that sort of bump up a little bit, some guys that bump up more, some guys that bump up more. And so there will be people who will say, you know, if you get an ROC of 0.6, and what that means is the area under the curve. So this is a unit square, so the area under it is 1, so the maximum value is 1. The area under this guessing is 50, so 0.6 is okay, 0.7 is good, 0.8 is great, and they say, you know, if you have 0.9, then you're cheating, or you're probably not doing something right. Again, this is one of those things where once you're digging into your data, you need to sort of look at that and say, you know, is this good enough for us? And you need to evaluate that and to sort of come up with soft numbers to say, like, this is great or this is not good isn't something that I feel comfortable saying.
All right. Are you familiar with the Data Science Design Manual? If so, what are your thoughts on it?
Data Science Design Manual. I'm not, so I can't really comment on that. Sorry.
All right, no problem. What is the MAGIN number?
MAGIN number. I don't.
Okay,
Is that part of our data frame up here?
It's okay to skip it.
Okay, we'll skip it.
What can we do with the RRADY made data set? I think they might have meant something else.
Yeah, I guess I'm not
Okay,
sure
no
what data set they're referring to.
All right, what we'll do, we'll come back now to some of the higher level questions.
Okay.
And we'll just take, if it's okay with you, take another 5 minutes and go 5 minutes.
Yeah, we're good.
How important is computer science to data science? Love this question.
Yeah. So you're going to get answers all over the board here. You're going to get people who say that you need to have a PhD to be a data scientist, or people are going to say you need to have a master's degree in some other field, and then you need to have sort of CS background. And you'll see, you know, there are people who are winning Kaggle competitions who don't have any background in computer science or whatnot. And for me, I think it's, if you can walk the walk, then I don't think a degree is that important. But I do think that most people who, you know, I get a lot of people like, do I need to have a degree? I'm like, no, you don't have to have a degree, but, you know, here's some like free resources, or here's some courses, or here's a boot camp.
Right.
And people don't do that because there's nothing sort of like holding them to it. So I think if you're motivated and disciplined to sort of go out and do projects and learn it on your own, you can do that. But for most people, I think they need sort of a degree or something, some carrot hanging in front of them to get them to act.
Right. Okay, and on the magic number, I think it was just a typo. It was magic number, which you already.
Oh, okay, the magic number.
Yeah, my colleague Ernst pointed out to me that I'm a dummy.
Yeah, so
Okay,
a magic number is just a number that's sitting in your code, and when your colleagues look at it, they're like, what is that number? It doesn't have any special meaning. And so we tried to refactor those or give them good variable names so people understand what they are.
Okay, how is data science different from big data like Hadoop?
Yeah, so one could say big data is where we have more data than will fit on one machine, and data science is the process of taking data and making some either predictions about it or prescriptions about it, what you should do. And so I don't necessarily think it's one versus the other. You can do data science on big data. You can do data science on small data. So pandas, I would say is small data. It's in memory, fits in your memory. But a lot of times people who have big data sets are actually sampling their big data and then pulling it down to something that fits in their memory and using something like pandas to do that. But as I said, with these new tools like Dask and Ray and Spark that implement the pandas interface, they also allow us to sort of use pandas to go out and use the full data set if we want to. Did we lose connection? Hello?
Oops, sorry, I was on mute.
Okay.
I need to become an expert in pandas. Is there any book or tutorial to follow which covers end-to-end pandas concepts? Is that your book?
Yeah, I mean, I think I'm biased. I like my book. As I said, I also do training. So I've got online O'Reilly training where I have 6 hours of pandas online where you can sort of try stuff out, you have access to me, live questions. So I'm biased towards that, but there's a bunch of other stuff that's available online. Follow me on Twitter, Dunder M. Harrison. I tend to tweet a lot about pandas and other people's pandas books and whatnot as well. So I try and read everything I can about pandas and share that. So there's a lot of stuff out there.
This one is more on our side. A couple of questions about should I use a Jupyter notebook interface or PyCharm? What's the advantage of using PyCharm connected to a Jupyter notebook? And lots of different ways to look at that question about sharing and the target audience and stuff like that. We kind of feel like the moment that you want to move from data science maybe to programming is when the value of PyCharm Professional kicks in. Refactoring, as you showed, navigation, as you showed, things like that. The rest of the machinery with version control and stuff like that.
Yeah.
What we would like to do is later this year have some more deep dives on data science where we might cover some of those kinds of things.
Yeah, I would note that like a lot of data scientists are pretty bad programmers. Like they sort of picked up programming on the side and have bad programming practices, and they're just living in Jupyter, and you'd sort of cringe if you saw what they did, but they don't know any better. So.
And as one of the people at Continuum explained to me, when data science kind of grows out of the exploratory phase and is part of the larger IT ecosystem at a company, it's going to need to interact with other kinds of systems and other kinds of code. And that might be another place where you might want to get over into an IDE.
Mm-hmm, exactly.
This is a question, feel free to say no thanks. What's the difference between a real data scientist and a fake data scientist?
I don't know. I'm probably a fake at everything, so I don't know that I'm good to answer that. I mean, as I said, my experience has been, if you can walk the walk and you can deliver what people want, I think you're real. And so title or past performance doesn't necessarily matter as long as you can hold your own. So get out there and try stuff out.
Data science only for someone who's good at math and stats?
So, I mean, some understanding of math and stats is important. I think it's good to have an understanding of math and stats, but I mean, using something like scikit-learn. Scikit-learn has this nice interface, and it's got all these models. You can cycle through these models, and you should have some understanding of the models because the models behave differently and might respond differently to, you know, different inputs. But I mean, you don't have to use it. You don't have to have any math or stats background. You can just say, let's fit this model and look at the score or look at the ROC curve and see how it behaves. There's no math or stats required for that. Where the math and stats comes in is just reading about how the model's implemented and sort of understanding how the model behaves and if it's going to be an appropriate model choice.
All right, great. We'll go ahead and wrap up here. Matt, you got anything that you want to say for closing comments?
I mean, like you said, I'm working on my new pandas book, which I think should be even awesomer than my other one. If you're interested in that, follow me on Twitter, and I'm going to be planning on sort of opening up for reviewers, people who are interested in reviewing it, and sort of getting a draft copy of that. But otherwise, you know, I'm super stoked about Python. I've been doing Python for a long time, and Python, you know, when I started using Python, we sort of had to hide it, and it's like, you can officially write Perl, but we can write Python and put like a PL at the end of it and change the shebang to Python just to hide it. But now Python has sort of taken over the world, and so it's a great place to be right now.
And just to help us out, I know there are a bunch of people listening who really should avail themselves of your training. Could you talk a little bit about what you do for Python training?
Yeah. So I run a company called Metasnake, and I do corporate training for that. So what I do is I take people who want to learn Python and sort of have access to someone who's been doing it for almost 20 years, do a deep dive, do beginning, intermediate. We do, and I also have a swath of data science courses as well. So that's, you know, if you're interested in sort of the corporate level, I'd love to talk to you and introduce me to whoever, and let's see what we can get you some good training. And then I also do a lot of stuff for O'Reilly. So this is more sort of, if you're the individual guy, I've got a bunch of courses on there. You can have access to me when I do live online training that way. And I do consulting as well. I think it's important to have some hands-on experience and be able to use sort of the latest and greatest, not just talk about it, but also talk about how it's being used in real life. So
it's tough standing up in front of a corporate audience and doing training for 5 days, isn't it?
Yeah. The hard part is when a lot of these companies, they're sort of saying, hey, Python's where it's at, you need to move there. And you've got a bunch of senior people who are like, I've been doing Java for 20 years. I don't really want to start with Python now. But most people come out pretty unscathed, but you can have a tough audience sometimes.
All right, well, we'll go ahead and switch over to my screen.
Okay, thanks, Paul.
All right, really, thanks a lot, Matt. That was fantastic. This is one of those webinars where the recording is going to be really valuable to go back and refer to later. We had a bunch of questions that we didn't get to. We do get a log of those, so we will try and get back to anybody that we didn't answer the questions on. If any of you do have any questions later about Python, data science, pandas, anything that Matt talked about, don't hesitate to reach out to us by email or social media. If you'd like to get more information on PyCharm, please go to our website at jetbrains.com/PyCharm. We'd love your feedback on this webinar, so please feel free to contact us on Twitter or in the after webinar survey. We read that thing carefully, so fill out anything that you can. And we'd like to give Matt some feedback on what you thought. The recording will be made available on our YouTube channel soon, and again, announced on Twitter and on our blog. If you haven't already, please check out that blog. Please check out the PyCharm blog, where you can find up-to-date PyCharm news about releases, which might be coming, you know, pretty soon, and other kinds of events, in addition to educational resources. So, for example, the recording of this webinar will be published there in a few days. We'll also provide some additional links and information from Matt's presentation on the blog. So that's all from us today. Thank you very much for joining us. Thank you very much, Matt. I hope everyone has a nice day.
Thanks, everyone.